Alright, testing. Introduction to Operation Theory, Absorption Technologies. Introduction to Operation Theory of Absorption Technologies. Contents. Introduction, Principles of Operation Theory. This publication is adapted from, this publication is adapted by the United States government, which are public domain, authorized but unlimited distributor, and are not copyrighted. Our introduction, purpose, the scope, purpose. The discussion provides the practical guidance for design, liquid vapor phase devices, absorption of organic chemicals, absorption media addressed for the insular, granular, activated carbon, other alternative absorption carbon media such as power activated carbon and non-carbon absorbents. Scope addresses various absorption media types, applicable use of various absorption technologies, equipment and ancillary component design, availability, advantages, disadvantages of refrigeration methods, cost, safety, sterilization, equipment can be installed alone, errors in part, overall treatment train based on on-site specific factors. Alright, background. Carbon in various forms has been used to absorb contaminants and sometimes first documented with the carbon absorbent with a medical purpose in the form of the wood char in 1550 BC. First documented use of the water treatment at 200 BC to remove the disagreeable taste. In 1785, experimental chemical learned that the carbon could accumulate unwanted contaminants from water. Carbon activated form was OBU, the first medium late 1800s. Originating carbon absorption progress in late 19th century and early 20th century when vapor phase organic compound was developed, given its first widespread use of defense against gas warfare during World War I. The first granular activated carbon filters water treatment in the United States were installed in Bay City, Michigan in 1930 and 1940. Granular absorbent carbons were found. Efficient purification separation technology, synthetic chemical industry by the late 1960s, early 1970s. The granular absorption carbons was found very effective by removing broad spectrum synthetic chemicals from water gases from vapor phases. Alright, abbreviations, acronyms: ASME, ASTM, AWWA, BDST, bed depth, service time, BET, Brunner-Emelett-Teller equation, BOD, biological oxygen demand, and it shows a list of the... Alright, 2. Principal operation theory. Type of absorption material. Activated carbon. Activated carbon is manufactured from carbonous material, including coal, bitumen, subbituminous, lignite, peat, wood, nutshells, coconut, and manufacture and process consists of two-phase carbonization activation. Carbonization process includes dyeing, then heating, separating byproduct, including tars or other hydrocarbons from raw material, as well to drive off any gases generated. Carbonization process is completed by heating material 400 to 600 degrees Celsius. Oxygen deficiency atmosphere that cannot support combustion. General carbonization particles activated by exposing them into an active agent with a steam, and the high temperature of the steam burns off the decomposition product of the carbonization phase to develop the porous three-dimensional graphite lattice structure. Size of the pores will develop during activation as function of the time they're exposed to steam. Longer exposure times result in a larger pore size of the most popular aqueous phase carbons. Bituminous phases are hardness, absorption resistant, pore size, distribution, low cost, efficiency needed to be tested in each application to determine the optimal product. Three-dimensional graphite lattice pore structure, typical activated carbon particles shown in figure 2.1. Powdered activated carbon powder activated carbon are made with a crushed and ground carbon particles 95% to 100% of which will pass through the designated mesh sieve or sieve. The American Water Works Association standards in 1997 defines granular activated carbon as being retained in 50 mesh sleeve, and powder activated carbon material is finer material. The ASTM classifies particle size to correspond with 80 mesh sieve and smaller with the powdered activated carbon. Powder activated carbon is not commonly used with a dedicated vessel, owing the high head loss that would occur with the power activated carbon generally added directly to the other process units such as raw water intake, rapid mixing basin, clarifies gravity filters. Alright, granular activated carbon. Granular activated carbon B with a granular form and extrude with the granular activated carbon designated by sizes such as 8 by 20, 20 by 40, 8 by 30, liquid phase applications 4 by 6, 8, 4 by 8, and 4 by 10 vapor phase applications 20 by 40. Carbon is base made of particles with it will pass the United States mesh number 20 sleeve, but must be retained in U.S. standard mesh sleeve number 40 sleeve. The AWWB604 uses 15 mesh sleeve as a minimum granular or activated carbon size. Most popular aqueous phase carbons are 12 by 40, 8 by 30 size because they have good balance size surface area with a head loss characteristic. The 12 by 40 carbon is normally recommended for drinking water applications where water contains low suspended solid content. 8 by 30 size most commonly used for most applications. Non-carbon, many activated absorption media with general surface today, removing the organic consistence from vapor and liquid streams. Organic modified clays, polymer absorbents, zeolite, and molecular sieves are primary not-activated carbon absorbent currently used with a hard waste treatment. Black and Vetch in 1998. And it shows a graphite plate, alphabetic dislocation platelet, intrabrowning platelets, 100 agritons. Atom part of molecule London dispersion force, part of graphite platate. Alright, properties of the granular activated carbon. Granular activated carbon properties are defined in ASTM D2652. In addition, with the properties following with the paragraphs of additional information, particle size distribution. Standard press procedure for the particle size distribution is defined in ASTM D2862. Information derived in the test is specified by the carbon particle size with uniformity, two particle size criteria effective with the size of the corresponding with the size C through 10% of the material will pass the uniform efficiency, which ratio is C size that will pass 60% of the material effective size. Determined with the rate of absorption, it will increase the particle size the degree of the process of the step of the diffusion of the carbon surface that should be enhanced by smaller particles. Note that another critical aspect of the rate of absorption of the pore size distribution and the development transport pores, which within the particle allow effective mitigation contamination for the point of absorption. However, the particle size may not be important in all cases. The pore nature of the carbon particles result in large surface areas and SARS carbon particles head loss, with the carbon bed increase with the particle size decreases uniformity coefficient increases. Surface area with a carbon particle available, the absorption in general, large area, surface area with a greater absorption capacity, however, with the surface area needed to be effective with a high degree of the areas needed to be an absorption pore region, as well as being accessible to contaminant with an effective transport structure. For capacity to be useful, measure determining the amount of the nitrogen absorbed by the carbon reported in square meters per gram, or ASTM D3037, and a divided procedure for determining the surface area with a nitrogen BET Brunner Teller method. Nitrogen is used because of the small size, which allows excess microporous carbon particles. Pore volume. The pore volume measures the total pore volume with the carbon particles in cubic centimeters per gram. Iodine number. The iodine number refers to the milligram 0.02 normal iodine solution absorbed during the standard test ASTM D4607. Iodine number is measured with the volume present in the pores of the 10 to 28 or 10 to 10 meters diameter. Carbon's high percentage of the pore size of the range will be suitable to absorbing low molecular weight substances from water. Carbons with high iodine numbers must be suitable to use the vapor phase. Carbon's water molecules tend to effectively block off isolate pore size less than 28A. Restricts mass transfer micropores, resulting pore carbon utilization excessive costs. Virgin liquid phase carbons generally have an iodine number of 1,000, and reactivated liquid phase carbon iodine number between 800 and 900. Alright, your molasses number refers to the milligrams of molasses absorbed during the standard test. Molasses number is the measure of the volume pores greater than 28A in diameter. Carbon a high percentage of the size pore suitable to absorbing high molecular weight substances such as color body and other colloids. Carbon's a high mass number, though generally used for decolorization process liquid. As such, molasses number, the specification is generally only used for the color removal application is not valid specification requirement for water treatment. This priority test should not be used with the specific granular activity carbon. Abrasion number. The abrasion number to measure for the ability of the carbon to withstand handling, slurry, transferred to different tests for the use of the based on the type of the carbon material. A road tap abrasion test of bituminous coal based on granular active absorption carbon, granular activated carbon of the centering abrasion test is used with a softer lignite coal based on granular activated carbon. Abrasion number of the ratio average final average mean particle diameter original mean particle diameter determined C's analyst times 100 desired average particle size of the granular activated carbon retained should be greater than or equal to than 70. This is of limited value because the measuring techniques are not reproducible. Procedures are given the AWWA B6004 apparent density. Apparent density is equal to the mass of the weight of the quantity of the carbon divided with the volume occupied, including pure volume and particle voids adjusted the moisture content. General bituminous made the general granular granular activated carbon have density of 28 to 40 pounds per cubic feet. Lignite based on the granular activated carbon has a density approximately 25 to 26 PCFs. Wood-based granular activated carbon has a density of 15 to 19 PCFs. Alright, your bulk density unit weight of the carbon with the absorbent generally bulk density liquid phase application 85 to 90% of the apparent density of vapor phase application 80 to 100% of the apparent density. Apparent density is used to determine the volumetric carbon use rate, since the carbon usage rate is typically stated in milligrams over grams or milligrams by milligrams contained removed over grams of carbon. Alright, isotherm is the relationship of the distribution of absorbent material absorbed between the absorbent phase of the absorbent and the source of the absorbent and solution phase of the equilibrium. Media manufactures the source of the absorption in the isothermers. Many manufacturers continue with the conduction of the research of the product and often supply specific chemicals, specifically absorption isotherms for the product. With how many of the companies isotherms batch isotherms use for its proof the concept of data actual work absorption capacity may be much less than equilibrium batch capacity because of the other constituent may be present in water such as the total organic carbon because of the non-instantaneous absorption kinetics. So you should carefully check with the manufacturer's data, use them on the caution when design. Absorption if the designer should add for the manufacturer with a contact with the insulation with the media so the scale factor for the commonly operational problems can be investigated. Granular activated carbon isothermers. Three general recognized mathematical relations developed and describe the equilibrium distribution solute between the dissolved liquid and the absorbed solid phase of the relationships help to interpret the absorption data obtained during the constant temperature test referred to as absorption isotherms. The Langmuir isotherm equation assumes that the fixed individual existing on the surface of the absorbent in each of these sites being capable of absorbing one molecule, resulting in a layer one molecule thick over the entire carbon surface of the Langmuir model would so assume that all sites absorb the absorbent equal. Brunner-Elmlet-Teller equation assumes the absorption surface composed with a fixed individual site. However, the Brunner-Elmlet-Teller equation assumes the molecules can be absorbed with one thick layer on the surface of the absorbent. The Brunner-Elmlet-Teller equation assumes the energy required to absorb the first particular layer adequate to the monolayer place. The Friend-Lewick isomer equation assumes the absorbent a heterogeneous surface composed of the absorbent sites with a different absorption potential. For this equation assumes that each of the class of the absorbent site absorb the molecules as is Langmuir equation. Friend-Lewick isomer equation is most widely used. We'll discuss further. Alright, X equals amount of soluble absorbed over mass of the absorbent in milligrams or grams equal to K time constant must be determined at each of the solute carbon type and temperature times concentration of solute remaining solution after absorption is complete. Equilibrium milligram liter times 1 to the nth. Example of the isotherm, the TCE is represented in figure 2.2 with the K within one end. N values multiple contaminant mixtures should be determined by laboratory tests. Alright, single component. Isomer may be used the order of magnitude of the carbon used to estimate with determined flexibility the granular activated carbon absorption using supplier's literature, previously published literature, Dobbs and Cohan, 1980, for the individual compounds. Another source of liquid phase isomer data constants for the EPA and readable database maintained with the Natural Risk Management Resource Laboratory, formerly known as Risk Reduction Engineering Lab. Vapor phase isomers are not readily available in literature. Some general rule of thumb using the cavates for the helpful in the isothermal information interpretation as follows: the flat isomer curve that indicates the narrow mass transfer zone, meaning that the granular activated carbon generally absorb the contaminants at the constant capacity relative to the wide range equilibrium concentration. Given the adequate capacity of the carbons exhibiting type of the isothermal will be very cost effective with absorption system design simplified owing short mass transfer zone. A steep isothermal curve indicated with a mass transfer zone with absorption capacity increased with equilibrium concentration increases. Carbon and exhibiting of the type of the isomer curve tend to most be affected. Change the isomer slope generally curve the ways of the containing the several compounds vary absorbent capacities. An efficient point of group the one compound preferably absorb the one other, and absorption occurs with a preferential absorbed compound can utilize sites previously used in less absorbent compounds. Figure 2.3. Isothermal to develop the data obtained with the laboratory with existing data for the natural risk management resource, laboratory treatable database, text, supplier literature. A typical example of the TCE isotherm data was obtained with the National Risk Management Research Laboratory databases provided in Figure 2. Polymeric clay videolite molecular seeds isotherms media developed in the same way with the carbon media. However, most of the isotherm data with non-carbon absorption media must be obtained from manufacturer laboratory tests. Isotherm testing. Although examples of specifically developed in liquid phase, the application of the vapor phase method is similar following paragraph to highlight the type of the information that can be obtained in the isotherm testing versus column testing. Isotherm static equilibrium tests are given the set of conditions ideal. The isotherm should not be used for a highly designed liquid phase system procedure. Laboratory developed an isotherm presented with a variety of the text. Banfield A 1982 specified ASTM D3860, although not advisable for liquid phase applications. Published absorption isotherm data is often used in the design vapor phase absorption system without bench or pilot testing. For same contaminant vapor phase with carbon, usually the higher absorptive capacity of liquid phase carbon because of less absorptive type sites will take up the water humidity less than at 100% relative to the humidity. The vapor phase carbon absorbs the capacity approach with liquid phase carbon absorptive capacity. However, we should remember that most published isotherm data represents single contaminant, pure, medium, mixed contaminants, many behave differently. Table 2.1 and 2.2. One source of published isomer, the absorption equilibrium data handbook that contains the gas liquid with the isotherms. Most of the isotherms activated carbon. There are some of the carbon molecular C with the silica gel zeolites. Source of information: Frangelic isotherm equation with carbon absorption. Isotherm toxic organic. Particular show the only 2 hours stress per day loop with a 24-hour period current be used by industrial standard. Liquid phase, the vapor phase application there because of the mass transfer characters of the two phases are different than mass transfer kinetics. Contaminant vapor phase to solid phase nearly instant, while mass transfer kinetics is bulk liquid phase with the solid phase influence pressure of the solute may be with a rare limiting in some of the instances of there are 4 phases of liquid phase absorption process. Contaminant must travel the bulk liquid phase to the liquid film surrounding carbon particles. Selecting the second contaminant must travel through liquid film surrounding carbon to the interstitial voids. Third contaminant may diffuse the carbon voids with the carbon solid phase. Fourth, finally, absorbed onto the carbon. More comprehensive discussion kinetics absorption can be obtained within text. From text, Fossielli in 1987. This is TACE isotherms, Figure 2.2. Figure 2.3, variable capacity absorption isomer, infection point. Our liquid phase isomers used with the screening tool to determine and the following absorption viable technology: equilibrium capacity, approximate capacity with a breakthrough. So preliminary estimate of the carbon use can be made relative to the difficult to remove the individual contaminant single constitute with the isotherms identified with the initial breakthrough compound. Change the equilibrium absorption capacity relative to the concentration contaminant of the waste stream. The effective change of the waste stream concentration. Maximum amount of contaminant absorbed with the granular activated carbon at given concentration. Relative efficient different type of the carbon to identify which should be used in dynamic testing. Liquid phase column testing will provide such data: the contact time, bed depth, treated time, Pre-treatment requirements carbon dose with head loss character of the breakthrough curves. Column tests identify how contaminants that are not regulatory concerns with the iron color containing compounds will affect efficiency treatment process. This shows a picture of the Fredlich absorption isomer constant toxic organic chemicals. A list of Fredlich absorption isomer constant toxic organic compounds. Fredlich absorption continued. Alright, dynamic operation test for the following parameters must consider with the design pilot scale evaluation. Breakthrough curve. The breakthrough curve is defined as S, the shape curve that typically results with the effluent absorbent and concentration applied with the nth time in the volume. Breakthrough curve can be constructed with full scale dynamic pilot testing. Breakthrough point with the breakthrough curve wherever the effluent absorbent or absorbative concentration receive the maximum allowable concentration, which often correspond with the treatment goal. The treatment goal is usually based on regulatory risk-based numbers. Or your mass transfer zone is the area with the absorbent bed, which absorbate equally to be absorbent on the absorbent mass transfer zone. Typically move the influent toward the effluent end of the absorbent bed during operation. That is, absorbent near the influent becomes saturated spent with the absorbent zone, with the activated absorbent move towards the effluent end of the bed. The absorbent is not yet saturated. The mass transfer zone is sometimes called the absorbent zone or critical bed depth. Mass transfer zone is generally bound between the spent carbon and the fresh carbon. The absorbent remove and dissolve the absorbent concentration levels from CO and CE. Length of mass transfer zone is defined as LMTZ. Length of mass transit zone is equal to bed depth because of the LCRIT, the theoretical minimum depth or necessary to obtain the desired removal. Adds absorption capacity and either the mass transit zone, the mass transit zone advance, mass transfer zone advance at the down the bed unit was absorbed and begin with the burn pure effluent. The concentration gradually increases equals influent concentration equal to where there are some very strongly absorbed components. In addition to the mixture loss strong with absorbing component with the fluent concentration very seldom reaches the influent concentration because of the components faster rate of the movement through the absorber. The breakthrough curve of the mass transfer zone is illustrated in figure 2.5. Absorption capacity influence many factors of the flow rate, temperature, pH, liquid phase of the absorption column may be considered the exhaust as fluent absorbent concentration equals 95 to 100% of the influent concentration illustrated in figure 2.5. And show the compensation, idolized vapor, liquid breakthroughs, liquid absorption, vapor absorption, maximal level, efficient concentration, breakthrough, volume of the ATH and water treated, effluent concentration, influent and effluent concentration. Shows used carbon, mass transfer zone, clean media, volume treated, effluent concentration. Alright, pilot tests. Pilot tests are also made with recommended liquid phase application bend scale isotherms provide with the proof of the concept data of the media of the pilot testing should be used to determine the size specific condition and interfere with the media with the testing solution, managing the interference. Pilot testing varying character of the breakthrough curve of the selected parameters such surface loading rates of the embedded contact times. For example, there may be a competition absorbent in sight as of different compounds waste stream. The analysis of the competing compounds may not be routinely conducted, so the presence of the concentration water stream would not be known, but the type of the competition may be minimized by selecting a product that selectively absorbs the carbon of the concern. As so variation of the water chemistry, pH, buffer capacity, etc. may affect the performance capacity of the absorbent. Pilot tests should also be generated scale-up factors of full-scale design. Several of the manufacturers have mobile pilot systems. Most of the manufacturers will for a free conduct pilot test of water streams for the customers. It may be possible to negotiate a packaging deal where testing costs would reduce it if the pilot scale manufacturer will be selected for full-scale project. There are two basic types of the column test that can be run to determine the parameter mentioned above. The standard pilot column test for the high-pressure micro column. To have the standard pilot column test consists of the one more carbon column series of the column of 50 to 150 millimeters in diameter, generally 1.8 to 3.6 meters, or 2 to 4 feet with granular activated carbon operated if either with a downflow upflow mode. Suspended solids are concerned with a full-scale operation. Downflow operation with a backwash capability to remove filtered solids is generally best option. In upflow, the solid would likely to plug. Most distributors' upflow operation typically generates carbon fiber and fines and thus great water. Downflow mode was generally preferred liquid streams, unless suspected with biological fouling. 4 pilot column was generally selected with the ensure the waterfront of the mass transfer zone can be tagged through the column. The column operates characteristic with the loading rate with detention time. Vertical velocity through the boat should similar to those expected with a full-scale system. Typical and full-scale water treatment application for the except of the large potable water plant have absorbent operating parallel with the mass transfer zone containing finer absorbent system have within 2 absorbent in the series. Unique process application for the contact time in series of several hours. 3 beds in series may be necessary for the various system of the 4 vessel series of the methods of the appeal. Apply to the data conditions such as the bed depth, surface time, board, arm, relationship, the operating line method describing the various references, and a typical pilot column configuration shown in Figure 2.6. Alright, a high pressure water mini column, or high pressure water mini column test of a small scale column test to develop in the length of time required to obtain the operational data from the column test. The traditional column test can take a month or more to run. The high pressure water mini column test must complete in a matter of hours. The high pressure water mini column process used to generally manufacture specifically depends on largely upon mathematical model giving particle size using the high pressure water mini column test parameters database fast test with experience of the individual interpreting test data with the apparatus consisting of 0.4 to 2 millimeters diameter column with a bed depth ranging from 10 to 100 millimeters. Uses sample subject with a granular activated carbon crust to pass 60 to 80 with much smaller. Micro column testing is generally about 1 order of magnitude less expensive than completely quickly. Requires a small volume of the water, having minimal chance of biological deterioration. Sample the multi-carbons and can be easily tested to obtain most effective design. Additional information can be obtained in testing labs. Carbon manufacturer American Water Association Water Quality Treatment in 1997. The typical apparatus shown in Figure 2.7 procedure for the estimating granular activated carbon performance using slightly larger diameter column of 25.4 millimeters plus 0.1 millimeter defined in ASTM D3922. Alright, spent carbon management. Spent carbon management, potential regulated disposal resource conservation recovery act. Spent carbon used in the treated list of hazard waste exhibit the Resource Conservation Recovery Act hazard characteristics. Inedible, corrosive, reactive, extending toxicity character of the teaching procedure threshold limits levels must be managed hazardous waste after using absorption process manifest to permit the Resource Conservation Recovery Act treatment, storage, disposal facility, either disposal or regeneration facility if it managed on the Comprehensive Environmental Response Conservation Liability Act. Permit is not submitted the requirement of the applicable to treatment, storage, disposal facilities must be met. On the other hand, would not even the treated listed waste does not exhibit the hazard character of the spent carbon can be disposed regenerated without being subject to the Resource Conservation Recovery Act, permitting and manifesting requirements for determining the determination of the Resource Conservation Recovery Act status, legal responsibility of the generator, operator, owner of treatment facility, coordinated with the carbon manufacturer, local regulatory specialists, and additional information. Figure 2.2 shows 2.6 shows the typical Polycom apparatus, alternate first feed, pressure gauge, influent backwash, outlet type, inlet type, sample port, porous plate, whirl, stainless steel, flow rate meter, effluent. 1/8 of an inch stainless tubing reduced in 2 millimeter inside diameter column, stainless steel, power activated carbon, glass wool, 5 stainless steel frit reducer, 1/16 Teflon tube. And then it goes into the course quiz, the introduction, absorption technology, operation theory, and that completes the J.P. Geyer PERA editor, PDH online introduction, operation theory, absorption technology, PDF read.